Alright, time for another draft physics video presentation. We have a mindless marbles answers to the questions. And yes, they're not complete evasions, but certainly complete evasions of logical implications. So he's not paying any attention to the fact that what he's saying isn't consistent with what physics says. So they're stories he's telling, essentially. And I'll just point out how, well, you just made that up. That principle hasn't been demonstrated anywhere. All right, so the first question is the space question, which I think really does get to the point. If I'm in space, not on Earth, in space, I don't know why that part's in there, and I throw a 2-liter bottle of Coke away, so I've now changed that to 2 kilograms, bottle of Coke, from me at 1 mile per hour, do I receive the same thrust if I shoot a dime away from me at 1,000 miles per hour? So a dime would be 0.2002 kilograms, 2 grams. 1,000. So the weight is 1,000 different, and the speed is 1,000 different. Okay, indicating it's all the same thing in terms of momentum. Okay, if so, isn't this proof against the kinetic energy formula? Now, I would say, isn't it proof against the formula if you believe in Newton's third law, for example? So if we accept Newton's laws, conservation of energy and, action equals opposite reaction, clearly I'm going to get the same thrust from both objects, and they're going to have the same energy, because I can't put more energy in one direction without having energy in the opposite direction. That's the third law, right? All right, anyway. So he says, if I have a mass of 100 kilograms, so now he's going based on the recoil, okay, and he's establishing how much the spaceship weighs, and that really wasn't what needs to be established. All we're establishing is how much energy went this way and how much energy went that way, and that tells us how much thrust we have because of the equal and opposite reaction. So again, he's just sort of ignoring the physical context of accepting that we're talking in Newtonian terms, that Newton's laws are correct. Okay, without violating Newton's laws, give me an answer. So he just gave me an answer that doesn't have anything to do with Newton's laws. Let's just understand. Okay, so anyway, so yes, let's establish this, but the spaceship weighs 100 kilograms. Who cares? And I throw a 1 kilogram bottle of water away from me at 1 mile per hour, I will have an opposite velocity at 1/100th of a mile per hour. So all perfectly correct, equal momentums, fine. But that's not what we're talking about. We're talking about your formula. We're not talking about momentum. We're talking about kinetic energy. So it's not true, in the sense that if you throw the bottle and you say it only has a kinetic energy of 1 joule, then you could just say, yes, I get 1 joule of thrust. Okay, and then he says, if I have a mass of 100 kilograms, same setup, and throw 0.00 kilograms, 1 gram, it's supposed to be 2, right? So this is supposed to be 2 kilograms up here and 2 kilograms down here, but it doesn't really matter. Instead of getting the answer of 2 joules, now it's 1 joule. Okay. Away from me at 1,000 miles per hour, I will have an opposite velocity of 1/100th of a mile per hour. So he's saying it's exactly the same recoil. So I just, shot 1,000 joules out, but I only did 1 joule this way. So I have a magic Newton third law violating gun now, frankly. Anyway, however, I will be to input much more energy. So that's how he wrote it. However, I will be to input much more energy to throw a dime at 1,000 miles per hour. Well, we know if you throw it with your arm, you can't do it at all. So obviously that's not the theory. So the theory is you have a device that makes the dime leave at 1,000 miles an hour. And whatever that device is, we know the opposite reaction is going to be the same. It just doesn't matter. Now, obviously, if the device itself, has a mass, still isn't going to matter, frankly. It's not going to matter, okay? All the equation requires you to figure out is that you have a certain amount of energy that leaves the spaceship, that is mass times velocity. And or you have to account for is the opposite reaction to that amount of energy leaving. All right. In fact, I need a ludicrous amount of energy to throw the dime. So how is it that I used a ludicrous amount of energy to throw the dime, and yet I only recoiled an unludicrous amount? So how can I throw with the catapult more energy, more stuff, more joules, and the catapult doesn't have the equal and opposite reaction? It doesn't care how many joules of energy I shoot. Okay, I don't get the equal and opposite reaction to the amount of energy I've put into the universe. So I can put the energy into the universe. So Newton's law doesn't really work, right? So you're just saying that Newton's law doesn't apply to kinetic energy is what you're saying. Newton's laws don't apply to kinetic energy. So we shouldn't even talk about Newton's laws because they're not relevant to anything that matters. Because kinetic energy, if it's right, is the only energy you should understand there to exist. Momentum can't mean anything if kinetic energy is correct. Why would I waste my time with momentum theory? Because it's not going to give me right answers. It's not going to tell me that I should be shoving Coke bottles out the window because I use so much less energy. It's so much easier to get the same amount of thrust. I just shove that little, that's so easy. I just push that and I get the same thrust as doing something that would take 2,000 joules, 1,000 joules worth of energy to do. So yeah, just keep pushing those big things. All right, anyway. The latter will require more input energy. And so why, if it has more input energy, why doesn't it have more output energy in terms of recoil then? If I input more energy, how do I avoid the equal and opposite reaction? So that's the simple question, the sub-question he completely ignored. All right. So the point in my question is, so isn't this proof against the kinetic energy formula if you believe in Newton's laws? I should have added. I don't see how at all. So you are conceding you have to use more energy that way to move the dime, and yet you don't have any recoil. There's no consequential recoil from applying more energy to the dime. I can apply more energy to a dime, I can add energy, and I don't have to have any recoil. So I can make the bullet go, say, twice as fast, and I don't have to accept twice as much recoil. That's what you're saying, overtly. Okay, where is the argument? Well, I just told you what the argument was. Okay, again, the context is you have to provide an answer that's consistent with Newton's laws. Okay, it's all just trivial arithmetic. Well, that's what you think the physical universe is, but it's, what you just did is trivial evasion. You just trivially evaded answering the real question, which is, how do you give the dime more energy without giving the spaceship more recoil? Explain to me how you do that. How you give the dime a ludicrous amount of more energy. A ludicrous amount of energy. Okay, how do you give the dime a ludicrous amount of energy without giving the spaceship a ludicrous amount of recoil? Okay, so that's all you can do, right? So it's just an evasion because I have to sit there and point out, oh, the question was asked in reality, okay? Not the fake-averse, but the real-averse. You have to have, your answer has to be in the context of the real universe, not a fake one where you can apply a ludicrous amount of energy and not have a ludicrous amount of recoil. Okay, so we'll just call that mush. Okay, question 2. Is there any physical evidence defending the kinetic energy theorem? Okay, so the first question isn't answered. Is there any physical evidence? There isn't any physical evidence. So we should just stop with that one and make that a separate question. Is there any physical evidence defending the kinetic energy theorem? In other words, is there any evidence of you actually collecting the energy above momentum that kinetic energy theory says exists? Okay. The theory says an 8-pound bowling ball will produce twice as much energy as a 16-pound bowling ball thrown with the same effort. Now, this is the video I showed where somebody linked to, which is just silly, where the professional bowler is, where the bowling instructor is explaining how in the book, a physicist tells them, the bowlers, that, yeah, this kinetic energy thing is real, and there's more power in an 8-pound ball. And he's believing the physicist. and he is actually instructing the people he's giving advice to and telling them, you should try to learn how to throw a lighter ball because the physics says it has more energy. So let's understand that's the real context here. Okay, no pro bowler can make a lighter ball work. Why? I mean, obviously, if the 8-pound ball has twice as much energy, that is, if we understand that it's kind of obvious that the bowler could probably throw the 8-pound ball twice as fast. It's obvious to me anyway, okay? So apparently some people think you can only get 0.4 increase in the velocity of the 8-pound ball. So, I mean, I just threw a 16-pound ball a certain velocity. All right, let's say, giving it one of my best efforts. And they say when I pick up the 8-pound ball, I can only make it go 0.4 faster than the 16-pound ball. 0.4. That's all I can get is 0.4 extra speed. 0.6. I can't make it go twice as fast. I'm 0.6 short of twice as fast. A ludicrous in a brokenness in me that I can't throw the twice as light thing twice as fast. Okay, so they won't show me any evidence of why humans can't do that. Why it isn't twice as easy to lift something twice as light. Somehow I only get 0.4 advantage. It's only 0.4. All right, anyway. Yes, all of thermodynamics, so we know this really isn't about thermodynamics, and fluid mechanics, we know this really isn't about fluid mechanics, is predicated on the concept of kinetic energy. So this little statement is, we've all accepted this, and this is what we've accepted, and we accepted it. That's all. It's part of our religion, the Holy Ghost. Yes, okay, it doesn't make any sense. It's still part of our religion. Yes, we use it, but it doesn't really do anything. It just sounds really cool. And God and Jesus and the Holy Ghost. La 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 la. Tiptoeing through whatever. The, mind field and the, blood and gut field. Anyway, if it were an incorrect notion, those fields would be completely falsified. No, they wouldn't. Just because obviously if you fuck up everything else, if you taint everything else with the same crap, then they're all got the same crap on them, and so then you can make them compatible. So if you're making the same, if you break everything else to fit, then you can still do something rational. But that's all they've done, is they've just broken all the other concepts to fit this stupid kinetic energy concept. All right. Plus, Cyrus Thornton. So the assumption was that you were going to answer this question as if you just heard it for the first time. So again, this is another thing we have to put before the questions. Please answer the question as if you're answering it and we don't have any previous history. Okay? Just answer the question as completely as possible. So he says Cyrus Thornton. I don't know. So I went looking for a Cyrus Thornton and I didn't have much luck, frankly. Okay, in a YouTube search for a channel, nothing comes up. So there was no channel. And then when I actually, did it on, his name, the initial search, YouTube's putting ads up to dox you. We found Cyrus Thornton. View his cell number and full address. So YouTube is promoting doxing people. I mean, it's that bad. They're putting up ads to these people. They think it's a great idea if we give all the crazy people who type shit in their stupid fucking YouTube, we give them everybody's name and address. It's so really cool that everybody has that so immediately accessible. Fuck. So anyway, it's a religious kook, right? So this was a useless reference, right? I mean, there's no other word for it, right? I mean, this is just useless crap to sit there and say, oh, I gave you the link. You didn't give me shit. You didn't give me any information about what the argument was here at all. You're just evading. All right, so where was I? All right, plus Cyrus Thornton has provided with countless, so another badly written sentence, has provided with countless amount of links describing the usage of the formula. So if this isn't an evasion, what is an evasion, right? He's not answering any of the questions here. Do you have any physical evidence? No. If the 8-pound ball is thrown with the same force, at least he's not falling back on the 1.4 thing, but he's just saying, I'm not going to give you an answer. I'm just going to reference some previous answer you've already debunked. Okay, so so let's just say we're not provided with any links describing anything. So that's just a lie. Okay, there's no Cyrus Thornton brilliance anywhere. Okay, so then he does the second part of the question. No pro bowler can make a lighter ball work. Why? Where is this claim from? Well, I guess I didn't think it would be an objectionable statement to make. But the fact is, I did watch bowling on TV for 10 years, maybe in my 20s or so. And, yeah, nobody ever won a tournament throwing an 8-pound ball. So I've never seen it. I've always seen it, like when the commentators talk, they all talk about everybody using the heaviest ball they can, blah, 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 blah. So there was no evidence that anybody tried to use a lighter ball. In all the experience I have with bowling personally, and in that context. I did go bowling as a kid, so I mean I know what bowling balls can do. Anyway, so how come he gets to make these lazy accusations? It's not a lazy accusation. It's completely consistent with, there's absolutely no reason to doubt it. So without good reason to doubt it, why wouldn't you accept the assertion? I mean, unless you want to just say I'm lying about it or something, why would I lie about it? And first off, and it's certainly a provable thing, and so why would I lie about it for that reason? And then second, what advantage is it making these arguments if there's a false premise, if all somebody has to do is link us to the 8-pound bowling ball champion? There won't be any such link because nobody's ever won a tournament throwing an 8-pound ball. So, yeah. Okay. So anyway, so that's just sort of horseshit, right? I mean, the concept is pretty clear. The argument's pretty clear that there is no evidence that 8-pound balls have twice as much energy and twice as much capacity to impose that energy on bowling pins. All right. Barry has already been provided with videos that dispute this. So that's a complete lie. There's absolutely no video showing a professional bowler winning with a lighter ball. There's certainly no video showing an 8-pound ball knocking down more pins. There's certainly no video anywhere about any of this. There's just the bowling video by the bowling instructor who tells you, I believe it, and you should try to learn how to do it. Right? And then there's the other video that was just saying, have fun bowling. So it was basically saying, if you like 8-pound balls, use 8-pound balls. It was a psychology video. So they studied bowlers and found out what made them happy. Okay? They didn't test whether 8-pound balls knock down more pins. All right. So it was complete garbage. So here he is. Instead of answering the question, he's referencing obscure shit that happened maybe 5 months ago. Okay? And was, of course, addressed by me in videos. The videos were played, and I responded to them and answered the fallacious nonsense that was the accusation in the video. By the way, but in any case, whatever that means, the problem is that you have to input much more energy in the lighter ball. Okay, so that's he is asserting that the lighter ball somehow, okay, to get it to the same velocity, double the velocity, I have to double my efforts and triple my efforts and quadruple my efforts, right? Because I'm only gaining 0.4. The ball's half as light and I only gained 0.4 with the same energy. So, I have a real, that's a huge deficit to overcome. I have to throw it essentially twice as hard to get to 0.8. Just to get to 0.8. And I'm still not twice the velocity. All right, so in this case, he has zero evidence that that's true. Okay, so we have no experiment where a guy throws a 16-pound ball, we measure the speed of the ball, and then he picks up an 8-pound ball and we measure that it's 0.4. That he can't throw it twice as fast. He can only throw it 0.4 faster. So I would argue that that's, on its surface, a claim that can be counter-argued, in that we all have personal experience with objects, and we know that the twice as light thing moves twice as easy. So there's this argument is going to be, you're going to have to make it in what context, in the sense that, in the physical context we all exist in, we know that twice as light is twice as easy, twice as heavy is twice as hard. I mean, those are impressions that are perfectly reasonable. So there's good reason to doubt your 0.4 theory. And the fact that no physicist says it is also another reason to doubt it, of course. That there's no physicist teaching the 1.4 theory. They're all saying momentum has to be conserved, that springs conserve momentum, that, there's an inverse relationship to mass to velocity ratios when it comes to energy and momentum, and that no, it doesn't. If it's half the mass, it's going to move, and you hit it with the same force, it's going to move twice as fast. That's what Professor Lewin says. So you're overtly saying he's wrong, and yet you're saying I have to prove you wrong. You don't have to prove you right. So you don't have to provide me a single shred of evidence. You won't let me say no professional bowler has won a tournament with a lighter ball, but you can say this without providing any physical evidence. You're just such a duplicitous hypocrite. Okay. All right. It has already been debunked. A half-mass, two-velocity object will compress the spring. We're on the wrong question. We're still up here. All right. The problem is that you input much more energy in the lighter ball. Nothing is free energy. Well, it's clearly free momentum or free energy, I've pointed out. If you keep both theories, you're screwed, because you either have a free momentum theory or you have a free energy theory, and either one is a free energy theory. Frankly, if you're making free momentum, you've got to be making free energy. All right, so either way, you're screwed. One of them is the correct answer. One of them is an incorrect answer. That's the only way it can possibly work. And I would argue that momentum always works. Kinetic energy doesn't ever work, okay, in terms of fitting Newton's laws. All right. So third question. If I shoot two objects with inverse velocity to mass ratios into gravity, okay, so that means a half mass object and a, twice as heavy object. Your formula says one object will have twice as much energy as the other at liftoff. So I lift them off with the same amount of energy. Okay, when one of them's going, well, let's just assume. Okay, I send two objects up, a half mass at twice the velocity. Okay, that's what inverse means. Inverse mass to velocity ratio. So one's leaving, regardless of what force launched them. One's leaving with half the mass, twice the velocity. The other one has a full mass and half the velocity. Okay. Formula says one object will have twice as much energy as the other liftoff. So the argument is that even though that sounds like two equal things, okay, even though Professor Lewin would say those are equal forces, the kinetic energy formula says one has four times as much energy, twice as much energy. The one half is in front of it. Twice as much energy. So the light object going twice as fast has twice as much energy, even though it has half as much mass. Okay, so if I let the objects fall on an identical spring, it will be recorded to impose the same pressure, the same joules of energy. So when they both land, okay, that experiment, it must be done somewhere. Well, anyway, the half mass object's going twice as fast. That's exactly how it's going to land. Is exactly how it took off. So it's going to land with more energy. Do you dispute this? How would you reconcile the fact with your theory? So he doesn't use the 1.4 thing, but he is saying it, I guess. So he says this has already been debunked. So again, instead of answering the questions, he's just saying, vague references to some previous argument somewhere. The 1/2 mass 2 velocity object will compress the spring more. So, and it will compress the spring more by a 1.4 ratio or a 0.7 or well, anyway, although the work on the spring is not linear with respect to compression distance. So that doesn't even make any sense. We know springs are linear. So that doesn't even make any sense. I mean, Professor Lewin would argue they're linear. He shows putting the extra weight on and the spring moves exactly the same amount. So if I add 1 kilogram, it moves this much. If I add another kilogram, it moves the same amount. If I add another kilogram, it moves the same amount. Same amount. Same amount. Same amount. Okay. So how do you reconcile the fact with your theory? There is nothing to reconcile because throughout these questions there weren't anything even close to a paradox. So obviously there's a paradox in the sense that the third law, Newton's third law, is violated by the space example. You somehow apply extra force to move the dime, but don't get extra recoil. So there's no extra opposite reaction to the extra force you push the dime with. All right. And obviously the other ones are basically the same argument. They're all premised on you believing that half as light objects do not move twice as fast, even though I have shown Professor Lewin saying that's how it works. So in spite of the physics professors saying so, you say it's 1.4 or some number, and you have no references and no links. So you've provided me no reference to any physical experiment demonstrating how springs don't give the same momentum back. And depending on what object I put on them, they give me a different amount of momentum. And if that is true, how that isn't free energy, because essentially all I have to do is compress springs with light objects, replace them with heavy objects, right? And I'll automatically get more momentum because the heavy object naturally wouldn't compress the spring as far as the light object did. So I'm winning. All right. Yeah, so that's it. So he did ask him the third question, which is the whole argument about momentum. As I've explained, there's no theory. They have no theory here. It doesn't make any sense at all for them to think they can transfer momentum 100% or 99% of the momentum, and yet they can lose half the energy. So the train example, for example, I can't deform a train. I can't break pieces off of the train. I can't do any of that kind of stuff without losing my momentum. I have to use my momentum to give it to pieces flying off. Therefore, I can't possibly make the other train move with my momentum because I gave it away already. So I don't have as much. So I can't possibly transfer my momentum and deform or create sound or create sparks or create any kind of energy. So if I lose half the kinetic energy, I have to lose it out of my momentum. How can I lose kinetic energy if I'm not losing it out of my momentum? How does anything besides momentum move something? I have to use momentum to move some other object. The only thing that can move one object to another object is momentum. That's why we still have the word, is because the only way you can make anything make any mechanical sense is to understand that. So nothing can travel through the universe with the same momentum and create friction, or create heat, or create sounds, or create anything. You can't deform anything, it can't rough up anything, it can't move anything, it can't transfer the energy to any little pieces, it can't hit hydrogen atoms, it can't do anything like that without losing its momentum. Fact. Evaded. Alright, so, and then there was this added comment. I should probably do this Walker one, it's so silly. He posted it in 2 locations and it's fucking retarded. Anyway, so then Mindless pinned this, that's 2 months ago, so it might not matter. It doesn't matter. It's just a gravity argument. Okay. But it's not, it doesn't say anything on the subject. It's really quite irrelevant to proving kinetic energy is a real thing in any way whatsoever. All right, so this Walker guy says, I've posted this question in the comment section of Steve's video. So he did on Steve's videos, Piero's video, and now this one on the same inane nonsense. Gary's answer was that negative distances don't exist. That was part of my answer. The first thing I said was, this is a stupid way to ask a question. I mean, what is this crap? You and Piero should keep asking him for the answer. What's it's such an inanely simple question. Why would I bother answering? You still haven't told me how much a stick of butter weighs when I drop it 1 meter. Why don't you answer my simple question, right? Everybody knows I asked that question in numerous videos. Why don't you just tell me the answer? How much does a stick of butter weigh? A quarter pound, 100 joules. How much does 100 joules weigh? 100 newtons. 100 grams. How much does 100 grams weigh after I drop it 1 meter? What's the instantaneous weight? That is the maximum scale deflection. Have you answered it? No. So why don't you answer my question? All right. Anyway, you and Piero should keep asking him for the answer. What, the answer's not going to be anything terribly interesting, but go ahead. But don't help him in any way. Since Gary wants to dismiss energy in favor of momentum, let's understand, I want to dismiss a religious theory, okay, kinetic energy, that started with mv squared, that was proven to be true by Clay experiments, and then was debunked by the very same scientists because they said, oh, screw that, that's way off. That answer sucks. So they proved it, and then they said that answer sucks, and they changed the formula. That's the history. Okay, yes, I want to just stay with Newton. Newton was right, did lots of great predictions. Newton. Fuck you idiots. Okay, Newton was smarter than you. Newton knew more than you, even though he knew less. He had less technical details, but he was still more right than you are. Okay, you can ask him how much momentum it will take to lift a shipment of coffee beans weighing 2,500 kilograms. So these are many tons, from -1 to 9 meters. So why would any idiot do -1 meter? What would a -1 meter look like exactly? That was my point. You can't have a minus distance. Okay, so in the physical universe, there is no minus different distances. You can't have a minus amount of water in a glass. I have -3 ounces. No, you can't do that. You can't have minus ounces. You can't have a minus distance. So we know that the distance you're talking about is really just 10 meters. So why don't you just say 10 meters? Or why don't you say, well, I dug a hole, and so you're going to do it from the bottom of a hole because I put the 2,500 kilograms into a hole in the ground. And yeah, the hole's 10 meters deep. So how much does it take to lift it out of the hole? This is such juvenile nonsense that you're saying, what the fuck is this crap? So you want to have a real physics conversation about a minus meter. There's no such thing. You just change where the zero is, idiot. The point of liftoff, they don't say, well, let's just imagine the rocket's lifting off from -1 meter. Because we're just going to make this up, right? So why don't we make it -1,000,000 meters? Yeah, we'll just forget about the idea of zeroing and neutralizing and normalizing. That's something physics does, normalize. You don't care about that idea, obviously, but you're defending physics. Don't forget, Gary is a heavy schizophrenic, so this is more nonsense. He's called anxiety disorder is due to the fact that he believes like this real life too, behaves like this in real life too. When he visits a bar, he will likely bounce out within 5 minutes. Like I said, I was a bartender for, a couple of years. Very well liked. Very personable. Very nice guy. Anyway, just hilarious nonsense. So 250 to 2,500 kilograms you just break that down into the Newton thing, right? So you say, well, how many sticks of butter is that? And so that comes out to 10, right? So now I have 25,000 sticks of butter, okay? And then you're just dropping it 10 meters. So it's 10 times 25,000, which would be 250,000 momentums. And if I want to turn the momentums, 250,000 momentums into joules, I can do that. I could just multiply by 2.3, and I'll get something like 500. So it would be about 500,000 joules to lift whatever number of tons that is, 4 or 5, 6 tons, whatever it is. How does that prove kinetic energy? Oh, that's right. It doesn't do anything. It doesn't enhance the argument at all. It was just a complete waste of time. Oh, fuck. I mean, I just hate this planet. All right, so we will wait for the mindless to answer the more relevant, even more pertinent question. All right, these are the old answers that were useless. Where's the... Okay, mindless. So he answered this question. No, this is the one. Yeah, okay. So this is the how do you ever move anything, create heat, create friction, create any movement in the universe without using something's momentum? So again, just explain to me how something can move into the universe, hit things, and not lose its momentum. That's the question, because that's what their theory requires. How could anything ever travel through the universe and cause events and not lose its momentum? How could you ever transfer momentum and deform an object? How can you lose the energy to heat and still transfer the energy to the object? I'm surprised I didn't just say right in here, how can you spill the paint and yet say you poured it into the bucket? Okay. You can't both transfer and deform. Yeah, so be nice to hear that answer. At least they'd have to concede that Physics Girl was way out of her mind to suggest half the energy deformed the train, and yet the train didn't lose any momentum. That would be really stupid. Yeah, they should at least be able to concede that. That can't be true. You can't deform the train, make heat, make sounds, make sparks, and keep your momentum. Can't do both. All right. That's probably enough of the video. My voice is going a little crackly, so it's probably a good enough time to quit. I don't think we have he's also asked that to Piro apparently, so we'll see if Piro answers. So we have no evidence still, no links to a single piece of physical evidence demonstrating the collection of the extra energy. That is, the spaceship says the same amount of energy went both ways. The dime has the same energy as the 2 kilogram Coke bottle. Same energy, according to the spaceship. What we need them to do is show us that that's not true. That when they actually extract the energy from the bullet, it actually hits more molecules and atoms in the universe. It actually makes more movement in the universe, more heat, than the 2 kilogram going 1 mile an hour. That's the experiment we don't have. Any experiment like that. We don't have one experiment showing us kinetic energy actually doing the work they claim the objects can do. They just claim it can do the work. They don't show us it doing the work. Show us the dime going 1,000 miles an hour, the tiny 1,000th of the mass, doing more work than the 2 kilograms going 1 mile an hour. Show us any example of that circumstance. But we'll never see that video because that experiment will never be done, because it can't be done, because that's not physics. That's the religion. Physics. We'll just change how we pronounce it. Theirs is physics. They're doing physics. Okay? It doesn't have anything to do with physics. Alright. Because it's just a silly religion. Poorly evidenced, poorly rationalized, and every bit of it is broken. Their theories are all really, 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 really weakly evidenced. None of their theories have any substantial evidence momentum. Nope. All just storytelling. religious kookery. Blah, 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 blah. So, this has been a DraftPhysics.com video presentation. Please join us for the next edition and such.